Let's do some homework problems. We're going to start with number 11, not because it's particularly difficult, but just because the wording is a little different than what you may have seen, and I want to talk about it a little bit. Okay, so number 11 says, rewrite in terms of sine of x and cosine of x. And specifically, it's the sine of x minus 3 pi over 4. So we want to write this in terms of sine of x and cosine of x. So we're going to have to use the angle difference formula. That's what it really means. It wants us to rewrite this, get rid of that pesky subtraction on the inside. It's going to be the sine of the first, cosine of the second, minus, rather, because for sine, they will be the same sign, and it's subtraction here, so it'll be subtraction there. Cosine of the first angle times the sine of the second angle. And while we've technically done what it asked, it should have also specified that it wanted us to simplify. I'm pretty sure it did. Pretty sure it wants us to simplify. But as the question's wording, this would be a fine final answer. What's 3 pi over 4? That's pi over 2 plus another pi over 4. The reference angle of pi over 4 in this quadrant. So we have this sort of dealio. We're going to get the sine of x times the cosine of that. It's going to be cosine's negative in that quadrant. We get negative 1 over root 2. Minus the cosine of x times the sine. Sine's positive in that quadrant. 1 over root 2. So we get negative sine of x over root 2 minus cosine of x over root 2. Factor out a negative and add them together. Sine x plus cosine of x over root 2 is a good final answer. Or the book may also write it as negative 1 over root 2 times sine x plus cosine x. Now, don't fall for the trap. This cannot simplify anymore. If it were sine squared of x plus cosine squared of x, then it would cancel to 1. But just sine of x plus cosine of that angle is nothing special. That's how you do these sorts of problems. Let's do 17 next. 17 says, simplify the given expression tangent of pi over 2 minus x. This just wants you to use a cofunction identity. So specifically the tangent, this is the angle that's complementary to x. So any trig function of an angle is its cofunction of the complementary angle. So what's the cofunction of tangent? Just add a co. Cofunction to tangent is just cotangent. All right. And it's complementary to x. X and pi over 2 minus x are complementary angles. So this is one way that we can use a cofunction identity. That's all there is there. 29. Simplify and then graph both expressions as functions to verify the graphs are identical. Confirm your answer with a graphing calculator. And again, you can graph these on Desmos. You don't have to copy these graphs down. I actually don't remember whether I specified that, but I really should. Okay, great. Made a note to myself to take care of that for you guys. 29 is the tangent of pi over 4 minus x. So it wants us to simplify first. Tangent of pi over 4 minus x. Be very careful. This looks like a cofunction identity, but that's pi over 2. Pi over 4 is different. That's 45 degrees. We're going to have to use the angle difference formula for tangent. So this is going to be, if I can remember it, tangent of the first minus tangent of the second divided by 1 plus, it's the opposite sign on the bottom for tangent, tangent of the first times tangent of the second. What's the tangent of pi over 4? It's 1. This is 1 minus tan x divided by 1 plus tan x. And again, you cannot cancel these. You can only cancel things if they have a common factor. But the top is prime. The top cannot be factored at all. Even though they look really similar, there's no simplification to be done. This is an interesting mathematical case, and these pop up every once in a while. You might say, Jason, isn't this red thing simpler? Well, yes and no. It depends on what you're doing with it. This lets us just evaluate tangent directly, even though it has more algebra. Whereas this is shorter to write. So we simplified, we did what it wanted, and now let's check that these are, graphically, let's check that these are both the same. Tangent of pi over 4 minus x. Looks like this. Is that the same as 1 minus tangent of x divided by 1 plus tangent of x? Oh, they look pretty samey. Great. There we go. 34. And let me actually just double check real quick that we did do everything it wanted us to do. I think we did. Simplify, check. Graph both expressions, check. Confirm they're identical, check. Now 34, use a graph to determine whether they're the same or different. If they're the same, show why. If they're different, then replace the second function with something that's identical to the first. So we're going to start by using a graph. 34, the cosine of 4x plus sine x sine 3x. Wait, I already forgot. Cosine of 4x plus sine of x times sine of 3x. That's kind of a weird looking thing. Is that the same as negative cosine of x cosine of 3x? Nope. They're not the same functions. But they're kind of similar, right? What does the problem ask us to do? Determine whether the functions are the same or different. All right, our answer is different. But they're close. Replace the second function with one that is identical to the first. So how do we modify the second function so it's identical to the first? Well, they're just opposites of each other, I think. If I want to check, let's take away that negative. There it is. So g of x should be the cosine of x times the cosine of 3x. And to answer the first part of the question, they were different. And that's all it wants you to do for something like 34. Sometimes they might be a little bit more complicated, and you might have to use some identities. But in general, that's a strategy. If you're curious about the identities part, let's do that now. 53. Prove or disprove the statements. Tangent of u. Wait, I don't want to do 53. 53 is literally basically how we started the fourth video, just with a minus. Let's do something more interesting. Let's do 54. That looks fun. Tangent of x plus y. Actually, this one looks boring too. Oh well. Tangent of x plus y. I don't know why it does this. Divided by 1 plus tangent of x tangent of y. Prove or disprove that this is equal to tan x plus tan y over 1 minus tan squared x tan squared y. Prove or disprove. So we'll start with the messier side and try to get to the easier side. And there's two ways of doing this because I don't know what you think is the messier side. So on the one hand, I want to start with the left because I can use the angle sum formula for tangent. But on the other side, that's kind of more complicated. So which side do you start with? And the answer is really just whichever side you see something that you can do. All right. So if you start with the left-hand side, you're going to use the angle sum formula and simplify, and that'll get you there. Feel free to pause the video and try that. Let's start with the right-hand side just to do something a little different. The right-hand side, well, we can't do anything with the top, but we can do something with the bottom. We can factor it. It's the difference of squares. This is 1 minus tangent x tangent y times 1 plus tangent x tangent y. And anytime you're doing these proofs, anytime you're trying to prove an identity, or in this case, disprove it, we don't know. We won't know until we get close. Anytime you're trying to prove or disprove, and if you ever get stuck, try to either go backwards, like reset the problem and try a different strategy, or look at the other side. Specifically, look at our denominator. We want this to be the denominator, and we have part of it in the denominator, so let's separate it out. Let's write this as, this whole first part of the fraction times just the denominator that we want. 1 minus tan x tan y. So we have the denominator, right? This is what we want our denominator to be. So is this the numerator? Because if this whole thing is the numerator, then we're done. And again, it is. Angle sum formula. Oops, I messed up, sorry. I checked, I looked up to see what the numerator was, but I looked too high. I looked up here, but this is what our numerator actually was. Tan x plus tan y. So yes, this is indeed angle sum formula for tangent. This first box is just the tangent of x plus y. Still multiplying it by this other thing. And again, multiplying fractions just multiplies the top, multiplies the bottom. We can write this as getting divided by 1. And so yeah, this will be tan x plus y divided by 1 plus tan x tan y. Which was exactly our left-hand side. We started with the right-hand side. We found that it equaled the left-hand side, so we have proven it. It says prove or disprove. We proved it. If we got something close, we'd say disproved. And you can always check your answers on these ones as well, graphically. It doesn't count for full credit, right? Because full credit is the whole proof for the whole disproof. But it can help you check to see whether you're on the right page. Let's look at this. What does the graph on the left look like? Tangent of x plus y divided by 1 plus tan x and y. Sorry, it's going to need parentheses around here. If you ever get an error, by the way, and are curious about why it's not graphing it, hover your mouse over here. Oh, specifically, so it didn't have a problem with what I thought I had a problem with. I'm losing my mind. This is a You can graph this. This would be a three-dimensional graph. This is a multivariable function. So if we actually wanted to test this, it'd be much more difficult. Tan x, tan y. Something that we actually could do though is we could replace this with some parameter. We could actually graph this function for any value of that parameter. Let's do that. Let's replace the y's with a, and we can still see this graphically. The right hand side is tangent of x plus the tangent of y. And again, we're calling y a here, divided by 1 minus tangent squared of each. So notice that again, for a equals 1, these are the same graphs. And for different values of a, they're still the same graphs. And as you change a, the graphs change. So again, what I'm saying is that earlier, why we couldn't graph it with x's and y's is there's too many variables. And there's a couple of ways of graphing things with multiple variables. One of them is to have a time graph. One of them is a heat graph, but the most common is just graph this three-dimensionally. But again, that's not part of this class. That's one way, one fun little way that you can check this with Desmos. Okay. Good luck. Enjoy. Hope this helped. And let me know if you have questions.